Now, in this lecture, we will find the size of the radius in a circle. As you can see in the drawing, we have a circle. The center of this circle is at point O. Chord AD of the circle equals to 10 units, and the chord BC equals to 5 units, and this angle equals to 90 degrees, and we want to find the size of the radius of this circle. First of all, we will define what is peripheral angle. Okay, so actually a peripheral angle so a peripheral angle is an angle that its vertex is on the circle and its curves are chords in the circle. So I will read again the definition of a peripheral angle. The definition of a peripheral angle is that a peripheral angle is an angle that its vertex is on the circle and its curves are chords in the circle. Okay, so I will give you an example of a peripheral angle actually angle alpha is a peripheral angle because the vertex of angle alpha is at point A, and point A is a point on the circle. Okay, point A, that is the vertex of angle alpha, is also a point on the circle, and also curve AB of angle alpha is a chord in the circle, and also curve AC of angle alpha is a chord in the circle. Okay, so the definition of a peripheral angle is that an angle that its vertex is on the circle, as you can see here. The vertex of angle alpha is at point A, and point A is on the circle, and its curves are chords in the circle. Curve AB and curve AC of angle alpha are also chords in the circle. Okay. In the next step, we will draw a chord through points A and O. You should remember that point O is the center of this circle. The touching point between the chord that I drew and the circle will be defined as point M. So actually chord AM is also the diameter of this circle, because of the fact that chord AM passes through the center of this circle. That is to say, chord AM passes through point O, that is the center of the circle. For that reason, chord AM is the radius, is the diameter of this circle. Okay, I will write it down. Chord AM is the diameter of the circle because it passes for the center of the circle. That is to say, it passes through point O, that is the center of the circle. For that reason, chord AM is the diameter of this circle. I will read again what I wrote. Chord AM is the diameter of the circle because it passes through the center of the circle. That is to say, it passes through point O, that is the center of this circle. For that reason, chord AM is the diameter of this circle. Okay? In the next step, we will connect together points M and D by a straight line. As you can see from the drawing, angle ADM rests on AM, that is the diameter of the circle. And we have a rule, I will call it rule number 1. Rule number 1 states that a peripheral angle that rests on the diameter of a circle equals to 90 degrees. So I will read rule number 1 again. Rule number 1 states that a peripheral angle that rests on the diameter of a circle equals to 90 degrees. Now I will give you example to clarify the rule number 1. So if AB is the diameter of this circle, and we have angle peripheral angle that rests on the diameter. As you can see from the drawing, this peripheral angle rests on the diameter of the circle. It rests on chord AB, that is the diameter of this circle. For that reason, according to rule number 1, it equals to 90 degrees. Okay? So, according to rule number 1, angle AOB equals to 90 degrees because it rests on the diameter of the circle. And I will give you another example of angle that rests on the diameter of the circle. Actually, angle APB rests on the diameter of this circle. That is to say, angle APB rests on chord AB, that is the diameter of this circle. For that reason, according to rule number 1, it equals to 90 degrees. Okay, so according to rule number 1, angle APB equals to 90 degrees because it rests on the diameter AB of this circle. Okay, so angle AOB that rests on the diameter of the circle equals to 90 degrees according to rule number 1, and also angle APB that rests on the diameter AB of this circle equals to 90 degrees according to rule number 1. Okay, actually we can implement rule number 1 in our circle. Because angle ADM rests on the diameter AM of this circle. Angle ADM rests on the diameter of the circle. That is to say, it rests on chord AM, that is the diameter of this circle. So according to rule number 1, it equals to 90 degrees. Okay? Again, angle ADM rests on the diameter of the circle. That is to say, angle ADM rests on chord AM, that is the diameter of the circle. Therefore, according to rule number 1, it equals to 90 degrees. So angle ADM that rests on the diameter of the circle, that is to say on chord AM, that is the diameter of this circle, equals to 90 degrees. So this angle ADM equals to 90 degrees according to rule number 1, because it rests on the diameter of the circle. It rests on AM, that is the diameter of the circle. For that reason, it equals to 90 degrees. Okay? In the next step, we will focus on the right triangle ADM. In the right triangle ADM, in the right triangle ADM, we will define angle AMD as alpha, angle AMD will be defined as alpha, and angle MAD will be defined as beta. Angle MAD will be defined as angle beta. Again, in the right triangle ADM, angle alpha equal angle AMD equals to alpha, and angle MAD equals to beta. Okay, that is according to our definition. Okay, according to our definition, angle AMD equals to alpha, and angle MAD equals to beta. Okay, and as you already know, in any triangle, the sum of the angles of any triangle equals to 180 degrees. Especially in the right triangle AMD, the sum of its angles equals to 180 degrees. Okay, so I will write it down. The sum of the angles of the right triangle ADM equals to 180 degrees. That is to say, alpha plus beta plus 90 degrees equals to 180 degrees. So actually, in this way we created equation number 1 that states that the sum of the angles in the right triangle ADM equals to 180 degrees. That is to say, alpha plus beta plus 90 degrees equals to 180 degrees. Okay, alpha plus beta plus 90 degrees, that is the sum of the angles in the right triangle ADM equals to 180 degrees. That is our first equation, equation number 1. In this equation, we'll subtract from equation number 1 90 degrees, so we subtracted from equation number 1 90 degrees. So alpha plus beta plus 90 degrees minus 90 degrees equals to alpha plus beta, and 180 degrees minus 90 degrees equals to 90 degrees. Okay? We will subtract from this equation alpha So we subtracted from equation number 1 alpha. We got that alpha plus beta minus alpha equals to beta, and 90 degrees minus alpha equals to 90 degrees minus alpha. So we got from equation number 1 that beta equals to 90 degrees minus alpha. That is equation number 1. Okay. In the next step, we will connect together points A and B by a straight line. We have rule number 2. Actually, rule number 2 states that peripheral angles that rests on the same chord, chord slash arc, chords or arcs, chords arc slash arcs, equal to each other. So I will read rule number 2 again. Rule number 2 states that peripheral angles that rests on the same chords peripheral angle that rests peripheral angles that rests on the same chord slash arc equal to each other. I will give you an example for rule number 2. So if we have two peripheral angles as you can see from the drawing, peripheral angle alpha rests on chord BC, and we have also another peripheral angle beta that rests on the same chord BC. So you can see in the drawing that peripheral angles alpha and beta rests on the same chord BC. Peripheral angle alpha rests on chord BC, and peripheral angle beta also rests on the same chord BC. So, because of the fact that both peripheral angles rest on the same chord, they also rest on the same arc BC. So because of the fact that both peripheral angles rest on the same chord BC, according to rule number 2, they are equal to each other. Okay, so according to rule number 2, peripheral angle alpha equals to peripheral angle beta because they both rest on the same chord BC. Actually, when they both rest on the same chord, they both rest on the same arc BC, okay? So because of the fact that both peripheral angles alpha and beta rest on the same chord BC, they are equal to each other. Okay? So angle alpha equals to angle beta according to rule number 2 because both angles rest on the same chord BC. Okay? So that is rule number 2, and I will repeat again that they both rest on the same chord BC, but they also both rest on the same arc BC. Okay? When they both rest on the same chord BC, automatically they also rest on the same arc BC. Okay? So because of the fact that both peripheral angles alpha and beta rest on the same chord BC, according to rule number 2, they are equal to each other. So alpha equals to beta because they both rest on the same chord BC. Okay? So we actually can implement rule number 2 in our circle because in our circle we have peripheral angle AMD that equals to alpha that rests on chord AD. Okay, I will write it down. peripheral angle AMD that equals to angle alpha rests on chord AD from one side, but we have also angle ABD. Angle ABD also rests on the same chord AD. Okay, but angle ABD also rests on the same chord AD. Okay, so angle AMD that equals to alpha rests on chord AD. Angle AMD that equals to angle alpha rests on chord AD, but angle ABD also rests on the same chord AD. Angle ABD also rests on the same chord AD. So according to rule number 2, both angles, the two angles that rest on the same chord equal to each other. So angle ABD equals to angle alpha. Angle ABD equals to angle alpha. Okay, so because of the fact that both angles, angle ABD rests on chord AD and angle alpha also rests on the same chord AD, according to rule number 2, they are equal to each other. So angle ABD equals to alpha. Okay, so according to rule number 2, because of the fact that angle ABD and angle alpha rest on the same chord, that is to say they both rest on chord AD, they are equal to each other. According to rule number 2, angle ABD equals to angle alpha because both angles rest on the same chord AD. Okay, so actually according to rule number 2, angle ABD also equals to alpha. So I write it here, angle ABD equals also to angle alpha. Okay, this angle ABD equals to also to angle alpha because both angles, angle ABD rests on chord AD and also angle alpha rests on the same chord AD. So according to rule number 2, they equal to each other, so angle ABD also equals to angle alpha. Okay, So now we'll focus on the right triangle. Actually, this angle equals to 90 degrees, so we will define this point as L, and in the right triangle ABL, we will define angle BAL as X. Angle ABL equals to X. Okay, so this angle will be equal to X according to our definition. Okay, so in the right triangle ABL, angle BAL, angle BAL will be defined as angle X. Okay, so in the right triangle ABL, angle BAL will be defined as X. So angle BAL equals to X. Angle BAL in the right triangle equals to X. Okay, so according to our definition, and we know that the sum of the angles in any triangle equals to 180 degrees. So the sum of the angles in the right triangle ABL equals to 90 degrees. So we'll create equation number 2 that states that alpha plus 90 degrees plus X equals to 180 degrees. Okay? The sum of the angles in the right triangle ABL equals to alpha plus 90 degrees plus X equals to 180 degrees. Again, the sum of the angles in the right triangle ABL equals to 180 degrees. That is to say, alpha plus 90 degrees plus X equals to 180 degrees. Alpha plus 90 degrees plus X, that is the sum of the angles in the right triangle ABL, and they equal to 180 degrees. So alpha plus 90 degrees plus X equals to 180 degrees, and this is actually our second equation that states that the sum of the angle in the right triangle ABL equals to 180 degrees. It is true for any triangle in the world. The sum of any triangle, the sum of the angles of any triangle equals to 180 degrees. Now we'll subtract from equation number 2 90 degrees. we subtracted 90 degrees from this equation, so alpha plus 90 degrees plus 6 minus 90 degrees equals to alpha plus 6, and 180 degrees minus 90 degrees equals to 90 degrees. Now we'll subtract alpha from equation number 2. We'll get so we subtracted 90 degrees from this equation, we subtracted alpha from this equation. We got alpha plus x minus alpha equals to x, and 90 degrees minus alpha equals to 90 degrees minus alpha. So equation number 2 states that angle x equals to 90 degrees minus alpha. Okay? But from equation number 1 states that beta also equals to 90 degrees minus alpha. Okay, so I will write it down. According to equation number 1, beta equals to 90 degrees minus alpha. Okay, according to equation number 1, beta also equals to 90 degrees minus alpha. Okay, from equation number 2 and 1 together, we can deduce that beta equals to x, or we can do it in the long way. Ninety degrees minus alpha equals to 90 degrees minus alpha, and we can substitute 90 degrees minus alpha from this side of the equation by beta, because beta equals to 90 degrees minus alpha, and we can substitute 90 degrees minus alpha from this side of the equation by x, because x equals to 90 degrees minus alpha, and we will get that beta equals to x. Okay, we substituted 90 degrees minus alpha by beta from this side of the equation, because beta equals 90 degrees minus alpha, and we substituted 90 degrees minus alpha from this side of the equation by x, because 90 degrees minus alpha equals to x, and we got that angle beta equals to angle x. Okay, so actually we can, in the drawing, instead of x, we know that x equals to beta, so instead of x, I will write beta. Okay, so angle BAL equals to beta. Okay, and actually we have angle MAD that equals to beta, and angle BAL also equals to beta. And we have rule number 3 that states equal peripheral angles rests on equal chords. Equal chords slash arms. So I will read rule number 3 again. Rule number 3 states that equal peripheral angles rest on equal chords slash arcs. Okay, equal peripheral angles rests on equal chords, or equal peripheral angles rest on equal arcs. Okay, so I will give you an example of rule number 3 in order to clarify it. If we have two peripheral angles alpha and we have another peripheral angle that also equals to alpha, so if we have two peripheral angles that both of them equals to alpha, or they equal to each other, then according to rule number 3, they rest on equal chords. that is to say BC equals to EF. Okay? So actually, because of the fact that those two angles equal to each other, they both rest on equal chords. That is to say BC equals to EF. Okay, so I'll write it down. According to rule number 3, BC equals to EF, or chord BC equals to chord EF, and also arc BC equals to arc EF. Okay, BC equals to EF because of the fact that those two angles equals to each other, they rest on equal chords. That is to say BC equals to EF. Okay, they rest on equal chords, and also they rest on equal arcs. We can also say that arc BC equals to arc EF. Okay, so because of the fact that those two angles equals to each other, they both equal to alpha, according to rule number 3, they rest on equal chords. That is to say BC equal to EF, and they also rest on equal arcs, and also arc BC equals to arc EF. Okay, what is important to us is that according to rule number 3, chord BC equals to chord EF because of rule number 3 that states that equal angles rest on equal arcs. That is to say arc BC equals to arc EF, or chord BC equals to chord EF because of the fact that those two angles equals to each other. They both equal to alpha. For that reason, they both rest on equal chords. That is to say chord BC equal to chord EF. Okay, so actually we can implement rule number 3 in our circle. So angle BAC equals to beta, and also angle BAC equals to beta, and also angle MAD equals to beta. Okay, angle BAC equals to beta, and also angle MAD equals to beta. Okay, so we have two peripheral angles that equal to each other. So according to rule number 3, they both rest on the same chords. That is to say, BC equals to MD. Okay, so according to rule number 3, BC equals to MD, or chord BC equals to chord MD. Okay, because of the fact that angle BAC equals to beta and also angle MAD equals to beta, according to rule number 3, they both rest on the same chords. That is to say, BC equals to MD. Okay, both those two angles beta rest on the same chord. That is to say, BC. This angle beta rests on chord BC, and it will be equal to this angle beta that rests on chord MD. So chord BC will be equal to chord MD. Okay, but we know it is given us in the question that chord BC equals to 5 units. It is given us in the question. We know that chord BC equals to 5 units, so we can deduce from it, from these two expressions, that chord MD also equals to 5 units. Okay, we can deduce from it that chord MD also equals to 5 units. So chord MD equals to 5 units. I can write it down. According to, because of the fact that BC equals to MD and BC equals to 5 units, it is given us in the question, so MD also will be equal to 5 units. Okay, so I will draw again right triangle AMD. So this is right triangle AMD. Side AD of the triangle equals to 10 units. Side MD of the triangle equals to 5 units. And AM is the diameter of the circle. So I actually marked it as D, that is the abbreviation for diameter. Okay, So side AM, that is the diameter of the circle, will be equal to D. Now we can implement the Pythagorean theorem in order to find out the size of side D, that is also the hypotenuse of this right triangle. Okay, first of all, I will write down the Pythagorean theorem. So actually the Pythagorean theorem states that in a right triangle, the Pythagorean theorem apply only to right triangles. So in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So I will read again the Pythagorean theorem. The Pythagorean theorem apply only to right triangles, so only in a right triangle the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, so we can implement this theorem in our triangle, and we can write down that the square of the hypotenuse, that is to say AM square, AM is the hypotenuse of this right triangle, AM, this will be our third equation, AM square equals to the sum of the squares of the perpendiculars equals to MD square plus AD square. Okay, according to the Pythagorean theorem, AM square, that is the square of the hypotenuse, equals to MD square plus AD square. Okay, but we know that AM equals to D, AD equals to 10 units, and MD equals to 5 units. So we can put the data inside equation number 3. So we substituted AM by D because AM equals to D. We got, instead of AM squared, D squared. We substituted MD by 5 because md equals to 5, so instead of md square we have 5 square, and we substitute that AD by 10 because AD equals to 10, so instead of AD square we got 10 square. And 5 square is 25 and 10 square is 100, and 25 plus 100 equals to 125, so I write it down. So we got that this square equals to 125. Now we will take out a root. We will take a root out of equation number 3. We got that d will be equal to root 125. Okay, we take a root out of equation number 3. We got that d equals to root 125. 125 equals to 5 times 25, or 25 times 5. So I write it down. Okay, instead of 125, I wrote 25 times 5, because 25 times 5 equals to 125. Now here we can split the root to 2 roots according to the rule that the square root of a times b equals to root a times root b. So in the same way we can split the root of 25 times 5 according to this rule. We'll get that so naturally split it to 2 roots, the root of 25 times 5. We got that d equals to, instead of 25 times 5, we split it to 2 roots. D equals to root 25 times root 5. The root of 25 is 5, so I write it down. So the root of 25 is 5. We got that d, the diameter of the circle, equals to 5 times root 5. As you already know, the diameter of any circle equals to 2 times the radius of the circle. Okay? The diameter of any circle, that will be our fourth equation, equals to 2 times the radius of any circle. Okay, we know that the diameter of any circle equals to 2 times the radius of any circle. but we already know that d equals to 5 times root 5, so we can substitute d by 5 times root 5 in the fourth equation. Okay, in the fourth equation we substituted d by 5 times root 5 because d equals to 5 times root 5. So we got that 5 times root 5 equals to 2 times the radius. Now we will divide equation number 4 by 2, and we'll get that the radius of the circle equals to 5 times root 5 over 2. Okay, we divided equation number 4 by 2. We got that the radius of the circle equals to 5 times root 5 over 2. Or we can also say that the radius of the circle equals to 5.59 units. Okay, so the radius of the circle equals to 5 times root 5 over 2 units, or in terms of numbers, we can say that the radius of the circle equals to 5.59 units. Okay, so the radius of this circle equals to 5.59 units, or 5 times root 5 over 2 units. So that is the answer to the question. Now I'll summarize the lecture. Actually, we wanted to find out the radius of this circle. And we know that the center of the circle is at point O. We also know that chord AD equals to 10 units and chord BC equals to 5 units, and this angle equals to 90 degrees, so angle ALB equals to 90 degrees, and we want to find out the radius of this circle. Okay, first of all, we will define what is a peripheral angle. Okay, a peripheral angle is an angle that its vertex is on the circle and its curves are chords in the circle. So actually we have example of peripheral angle. Alpha is a peripheral angle because its chords is point A. Point A is the vertex of angle alpha is at point A, and point A is also a point on the circle. Okay, point A is the vertex of angle alpha, and point A is also a point on the circle, and the curve AC of angle alpha is also a chord in the circle, and also curve AB of angle alpha is also a chord in the circle. Okay, so a peripheral angle is an angle that its vertex is on the circle. The vertex of angle alpha is at point A, and point A is also a point on the circle, and its curves are chords in the circle. Curve AC of angle alpha is a chord in the circle, and also curve AB of angle alpha is a chord in the circle. Okay, so actually that is the definition of a peripheral angle, and we actually drew a chord through points A and O, and you should remember that point O is the center of this circle, and the touching point between the chord and the circle is at point M. So actually chord AM is the diameter of the circle, because it passes through the center of the circle, that is to say, it passes through point O. Chord AM passes through point O, that is the center of the circle. For that reason, chord AM is the diameter of the circle. Okay? Then we connected together points D and M by a straight line, and as you can see from the drawing, angle ADM rests on chord AM, that is the diameter of the circle, and we have rule number 1 that states that a peripheral angle that rests on the diameter of a circle equals to 90 degrees. So because of the fact that angle ADM rests on the diameter of the circle, according to rule number 1, it equals to 90 degrees. So angle ADM equals to 90 degrees according to rule number 1. Okay, because if you have in this circle, if AB is the diameter of the circle, you have angle AOB that rests on the diameter. It equals, according to rule number 1, it equals to 90 degrees. And for the same reason also angle APB that rests on the diameter AB of the circle also equals to 90 degrees according to rule number 1. Okay, So angle ADM equals to 90 degrees according to rule number 1, because it rests on the diameter of the circle. And in the right triangle ADM, we defined angle AMD as alpha, and we defined angle DAM as beta. That is according to our definition. And we know that the sum of the angles in any triangle equals to 180 degrees. So we can write down equation number 1 that states that the sum of the angles on the right triangle ADM equals to 180 degrees. That is to say, alpha plus beta plus 90 degrees, that is the sum of the angles in the right triangle ADM, equals to 180 degrees. The sum of the angles in the right triangle ADM equals to alpha plus beta plus 90 degrees, and according to the known rule, the sum of the angles in any triangle equals to 180 degrees. We subtracted 90 degrees from equation number 1, we got that alpha plus beta equals to 90 degrees. Then we subtracted alpha from equation number 1, and we got that beta equals to 90 degrees minus alpha. Okay, and we also have rule number 2 that states that peripheral angles that rest on the same chord / arc equal to each other. Okay, first of all, we collected together points A and B, and angle AMD rests on chord AD, or we can say that angle alpha rests on chord AD, and angle ABD also rests on the same chord, that is to say it rests on chord AD. And actually, according to rule number 2, if we have two angles, alpha and beta, that rest on the same chord, BC, it can also be the same arc, it doesn't matter. So if alpha and beta rest on the same chord, in this drawing we have alpha and beta that rests on the same chord BC, according to rule number 2, they equal to each other. That is to say, alpha equals to beta because they both rest on the same chord BC. Okay, so we can implement this rule in our circle because we have angle alpha that rests on chord AD, and we also have angle ABD that rests on the same chord AD. For that reason, according to rule number 2, they are equal to each other. So if this angle is angle alpha, this angle is also angle alpha because both of them rest on the same chord AD. Okay, so angle ABD equals to alpha. Okay, and we will focus on the right triangle ABL. We know that this angle is 90 degrees, it is given us in the question. For that reason, triangle ABL is a right triangle. We define the angle BAL as angle X, and we know that the sum of the angles in any triangle, especially in the right triangle ABL, equals to 180 degrees. So we actually can write down that the sum of the angles in the right triangle ABL equals to 180 degrees. And this will be our second equation that states that the sum of the angles in the right triangle ABL equals to 180 degrees. So actually alpha plus x plus 90 degrees equals to 180 degrees. That is the second equation. Alpha plus 90 degrees plus x, that is the sum of the angles in the right triangle ABL, equals to 180 degrees. Okay, we substituted 90 degrees from both sides of the equation, then we substituted alpha from equation number 2, and we got that angle x equals to 90 degrees minus alpha. Angle x equals to 90 degrees minus alpha. But we know from equation number 1 that beta also equals to 90 degrees minus alpha. So we can deduce from equation number 2 and 1 together that beta equals to x. So instead of x, I write that angle BAL equals to angle beta. So we know that angle MAD equals to angle beta, and also angle BAL also equals to angle beta. So we have two peripheral angles that equal to each other. They both equal to beta. So according to rule number 3, equal peripheral angles rest on equal chords slash arcs. Okay, equal peripheral angles rest on equal chords slash arcs. So actually, if we have two peripheral angles that equal to each other, in this example they both equal to alpha, then according to rule number 3, they both rest on the same, on equal chords or arcs. That is to say, BC equals to EF, because of the fact that the angles equal to each other, then they rest on equal chords. That is to say, BC equals to EF according to rule number 3. And they also rest on equal arcs. We can also say that arc BC equals to arc EF, but what is important to us, that chord BC equals to chord EF because of the fact that the angles equal to each other. According to rule number 3, chord BC equals to chord EF because they both equal to each other. Okay, so we can implement rule number 3 in our circle. We have angle beta that rests here, that rests on chord BC, and angle beta, this angle beta also rests on chord MD. So according to rule number 3, those chords equal to each other because of the fact that the angles equal to each other, they both equal to angle beta. The chords that they rest on also equal to each other. Okay, because of the fact that angle BAC equals to beta and also angle MAD equals to beta, according to rule number 3, the angles that equal to each other rest on equal chords. That is to say, BC equals to MD. BC equals to MD. Okay, but we have already know that BC equals to 5 units. It is given us in the question. BC equals to 5 units. So BC equals to MD and BC also equals to 5 units. So we can deduce from these two expressions that MD also equals to 5 units. Okay? We can deduce that MD also equals to 5 units. So I do right triangle ADM again. So right triangle ADM, the right triangle ADM, AD equals to 10 units, MD equals to 5 units, and AM, it is the diameter of the circle. So I marked it as D, that is the abbreviation for diameter. And we have the Pythagorean theorem that states that in a right triangle, the Pythagorean theorem apply only to right triangles. So in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, so in our specific right triangle, we can say that the square of the hypotenuse, that is to say AM square, equals to MD square plus AD square. Okay, AM square equals to MD square plus AD square, but we know that AM equals to D, MD equals to 5, and AD equals to 10, so we can put the data inside the equation, and we got that the diameter of the circle equals to 5 times root 5. Okay, but we know that the diameter of any circle equals to 2 times the radius. Our fourth equation states that the diameter equals to 2 times the radius. What we have already know that the diameter of this specific circle equals to 5 times root 5, so we can substitute D by 5 times root 5. And we got that the radius of the circle equals to 5 times root 5 over 2 units, or the radius of the circle equals to 5.55 units. So the answer to the question is that the diameter of this circle equals to 5.55 units. Okay, thank you very much.